Hello. Now I continue the next lecture of the reinforcement learning. In this lecture, I explain the deep reinforcement learning. Okay, in previous lecture, I explained the relation between the artificial intelligence, machine learning, deep learning, uh, reinforcement learning. Okay, now the intersection of the combination of reinforcement learning, deep learning is called a deep reinforcement learning. I introduced them in the previous lecture. Deep reinforcement learning is the deep learning neural networks plus reinforcement learning task is called a deep reinforcement learning. Deep learning neural networks plus reinforcement learning task is called a deep reinforcement learning. We are using deep learning techniques to solve the reinforcement learning task in different aspects, in different phases of the reinforcement learning process. This is called a deep reinforcement learning. Okay, reinforcement learning is a generic framework for representing and solving the control task, a decision making task. Within the framework, we are free to choose any algorithm we want to apply for the particular control task. Okay, we can have the freedom to choose any algorithm. Any algorithm we can choose to solve the particular task in reinforcement learning framework. So in this way, in this process, we are using the deep learning algorithms to solve the reinforcement learning task in different different applications in reinforcement learning. Okay, deep learning is a subset of machine learning. The deep learning can be used as the learning algorithm for reinforcement learning. The reinforcement learning is a framework for solving control tasks. This is the relation between the deep learning and reinforcement learning. We are using combinationally, that is the deep reinforcement learning. The deep learning is used can be used as the learning algorithm for reinforcement learning. The deep learning is used as the input to the reinforcement learning. The reinforcement learning acquire the data, acquire the knowledge from deep learning algorithms to solve the control task. To solve the control task. In the deep learning algorithms, we are using the different perspectives, different tasks like a functional approximation, feature extraction, scalability, end-to-end learning, and combining the exploration and exploitation. Okay, in reinforcement, these are the primary tasks: the function approximation, feature extraction, scalability, end-to-end learning. Combining the exploration and exploitation tasks, we are using the deep learning algorithms. I explain the one by one. Function approximation. In function approximation, the reinforcement learning main objective is to acquire the maximum reward. To acquire the maximum, how to get the maximum reward? By using, we have the knowledge which action has a which reward is, we get the knowledge by using policy. The policies we are using, how to get the policies? By using value functions or q value functions we are using to get the policies. So if the policy functions are working with the minimal or simpler models, the policy functions are applicable, we are using with the simple problems. But the huge amount of data, if you are working with a huge amount of data, the q value functions and value functions are not suitable, and they are face the problems. So in that case, we are using the deep learning algorithms in function approximators to as a in reinforcement learning task. The high dimensional data, in high dimensional data we are using the reinforcement learning task. In that case, we are using the deep learning techniques for get the function approximations, means the actions and rewards are mapping or get from deep learning. The reinforcement learning get the actions and corresponding rewards knowledge is get from deep learning algorithms when it is working with high dimensional inputs. Okay, that is the function approximations we are using deep learning algorithms. Next, feature extractions. The deep learnings are using the neural networks. They are automatically, the deep learnings to perform the feature extraction, feature selection process is automatically done in the deep learning. So in feature extraction, the automatic vehicles, automatic driving vehicles, we are extract the surroundings, images, surrounding objects. That objects are we are get how by using deep learning. The deep learning is used feature extraction in reinforcement learning task. Next one is scalability. Scalability means the smaller to huge amount of data scales. We are using the deep learning techniques for, they are suitable for any small data or huge amount of data. Both are any scale, the deep learning techniques are suitable for working. So the reinforcement learnings are using the deep learning techniques for any scalability of data. Next, end-to-end learning. End-to-end learning means the deep reinforcement learning allows the end-to-end learning where the agent can learn directly from the raw data. Directly from the raw data, like in video game, pixel surroundings, pixels are video games, the surroundings, surface surroundings, where object detections are performed with deep learning to take the decisions. So it simplifies the end-to-end learning, simplifies the learning process and can lead to the more robust and generalized policies. So end-to-end learning also we are using deep learning techniques and combining the exploration and the exploitation. Exploration means try the new actions. The deep learning techniques are using the try the new actions to check the rewards and what are the available actions, available rewards, which one is the best one is choosing. That also we are using deep learning techniques to explore the actions and to exploit the actions. Both are done with the deep learning in reinforcement learning task. Okay, these operations we are using deep learning techniques. Deep learning techniques used in reinforcement learning tasks for functional approximation. And functional approximations means the action rewards mapping we are get from deep learning as the input to the reinforcement learning. Feature extractions, deep learning techniques also we are using for feature extractions and scalability of the data and end-to-end learning process and combining the exploration and exploitation task also done. These all operations are done with the deep learning and deep learning gives the input to the reinforcement learning to solve the problems. That's why it's in deep reinforcement learning sentence, the deep indicates that it is a deep learning is used in the learning process. Deep is used as a learning process. Can be used, deep learning can be used as a learning algorithm in reinforcement learning. That's it's called a deep reinforcement learning. Next, real world applications of the deep reinforcement learning. In real world applications, there are so many real world applications, but I explain some real world applications with deep reinforcement learning. Deep reinforcement learning means deep learning plus reinforcement learning. Deep learning is a learning method for to solve the reinforcement learning task. Reinforcement learning is the main objective of reinforcement learning is to get the best action, to get the best decision, how to take the best decision. Okay, in autonomous vehicles, we are using the deep reinforcement learning techniques. Autonomous vehicles, the surroundings objects are detected by using deep learning techniques. According to the deep learning input, the reinforcement learning take the decision like accelerating or braking or turning. Decisions are taken by the reinforcement learning. So in autonomous vehicles, we use the deep reinforcement learning. Deep learning for object detections and reinforcement learning for action decision making. And next one is robotics. In robotics, deep reinforcement enables the robots to learn tasks such as the manipulation, navigation and interaction with objects. For example, the robotic arm can learn to pick the objects and place the objects. This knowledge is acquired according to the rewards of the environment. Okay, this knowledge, the surrounding observations are done by with the deep learning and rewards are evaluated by using reinforcement learning tasks. So robotics use the deep reinforcement learning. Deep reinforcement learning used for surrounding observations and reinforcement learning evaluate the rewards of the robotics. Okay, robotics is the deep reinforcement learning. Next one is the game playing. Video games, the actions are taken by the reinforcement learning. How to choose the actions? By observing the surroundings. Observe the surroundings, observe the state of the environment. This state of the environment features are extracted by using deep learning. The features, environment state is observed. Environment state is observed by deep learning, and based on that state, the actions are taken by the reinforcement learning in game playing. Next one is financial and trading. In financial trading, we are taking the best decisions. The decisions are either buy or sell or hold the decisions. Okay, these decisions are taken by the reinforcement learning. The analysis operations are done by with the reinforcement learning. Next one is healthcare. The patient personalized treatment planning. We are using deep reinforcement learning technique to analysis of the patient data by using deep learning, and decisions are taken by using reinforcement learning. Based on the deep learning analysis, the recommendations of the treatments are done by with the reinforcement learning tasks. Next one is energy management. Energy management is using the deep reinforcement learning. It optimizes the energy consumption and distribution. It is best utilization of the energy resources efficiently and balancing the supply and wastage of the, reduce the minimize the wastage, and it is best analysis of the analysis operations are done with the deep learning algorithms. Reinforcement learning are used for decisions. Natural language processing. Natural language processing is what are the natural language processing of the dialogues, translation, machine translations, and chart. These are the natural language processing. In the natural language processing, the user satisfied. It is the deep learning techniques are generate the statements according to the translation. It's the statements, but the translations are how. Based on the user satisfaction, the user satisfaction is calculated by using the reinforcement learning technique, and in generation of the natural language operations are done with deep learning. The user satisfaction is calculated with reinforcement learning, and deep learning is used to analyze the and generate of the natural language translation statements or charts. All are is done with deep learning techniques. Okay, these are the applications of the deep reinforcement learning. The deep reinforcement learning, deep learning is used for feature extraction and function approximation. Okay, these are the applications of the deep reinforcement learning. Okay, autonomous vehicles, robot, deep reinforcement learning techniques are we are using in autonomous vehicles, robotics, game playing, finance and trading, healthcare, energy management, and natural language processing. Okay, in this lecture I explained what is deep reinforcement learning, where we are using deep learning in reinforcement learning task, and what are the applications of the deep learning techniques. Okay, thank you. This is about this today, this lecture. Okay, thank you.